Question number 51 is active mass of 5.6 gram of calcium oxide is. So whenever we talk about active mass, we should first check the state of the substance. If we talk about calcium oxide, it is solid. It's also given in the question that it is in solid state, and whenever a solid substance is there, its active mass is always assumed to be 1 or unity, and that is why in this case its active mass CaO in solid state is 1, and the correct answer, easily you can mark, it is option 4. Now, after this, question number 52. Question number 52. The value of equilibrium constant for the reaction N2O5 in the gaseous state is getting changed into 2NO2 in gaseous state, and oxygen is also formed here, and the value of equilibrium constant is 0.5. The equilibrium constant for another reaction, that is the combination of NO2 with O2 to give you N2O5, is, you have to calculate the equilibrium constant for this second reaction. Here first we'll consider the previous reaction, that is N2O5. The gaseous state is getting changed into nitrogen dioxide and oxygen. In this case, the equilibrium constant is equal to NO2 raised to the power 2, O2, 1 by 2 divided by N2O5, and for this the value is 0.5. it is given in the question. Second reaction, this was the first reaction. In the second reaction there is 4NO2 combining with O2, giving you 2N2O5. This is the reaction. Now what would be the K equilibrium for this particular reaction? Say this is K dash equilibrium. The equilibrium constant for this reaction can be calculated using this equation. Now just compare reaction 1 and the reaction 2, and you can easily identify that this K dash equilibrium is 1 upon K equilibrium square, and if you place the value here, you will find out that this is 0.5 square, this is 1 upon 0.25, and that would be 4, and that's the correct answer for this particular question. I hope this question is clear to you. Now let's check the next question. Question number 53. Which among the following is an acidic buffer? What is acidic buffer? So I just want to make it clear that whenever we talk about acidic buffer, this is the mixture of a weak acid and its salt. That salt is formed by the reaction of that weak acid with a strong base. So in the first case we have acetic acid and HCl, it cannot be a buffer. Further, acetic acid is given and the salt of acetic acid is also given, and that salt is prepared by the reaction of acetic acid and a strong base, that is NaOH. So it is an example of acidic buffer. And further, if we look at other option, option 3, it's a mixture of two acids, it's not a buffer. Further, ammonium hydroxide is a base, and further this NaOH is also a base. So which is the acidic buffer? The example of an acidic buffer is given in option 2, And that's why the answer for this question is also option 2. After this, take the next question. Question number 54. pH of 0.1 normal NaOH aqueous solution is, we know that the pH value is negative logarithm of hydronium ion concentration. But if you're talking about the pH of a base, first we have to look at the pOH value of this NaOH. We just have to calculate first, and with the help of that you can calculate the value of pH also. So what would be the pOH value for this base? That would be negative logarithm of hydroxide ion concentration. And if we talk about the concentration, here is given that the concentration is 0.1 normal. What is the acidity of this NaOH? That is 1, and factor is 1 there. That is why this is 0.1 molar. Now, after this, let's place the value to calculate this pOH. It would be negative log of 0.1, and that would be equal to 1. And if pOH is 1, so definitely the pH value is 14 minus 1, that's equal to 13. And on the basis of this, the correct answer is given in option 4. So the answer for this question is option 4. Now, let's check the next question. Question number 55 is here. pH of a solution of 0.1 molar ammonium acetate is given. The Ka value for acetic acid is equal to the Kb value for ammonium hydroxide, and that is equal to 1.8 into 10 to the power minus 5. So this question can be solved with the help of a simple formula, that pH of a salt. What we need to do, we have to just consider the formula 7 plus half of the pKa minus pKb. pKb, where this Ka value is for acetic acid and this Kb value is for ammonium hydroxide, because we are talking about ammonium acetate salt. So in this case, let's place the values here. 7 plus half. We know that here Ka value is equal to Kb value. So definitely this term pKa minus pKb would be 0. And on that basis, the pH would be 7 only. And if it is so, the correct answer is option 3. So I'm just writing here the correct answer, that is option 3. I hope this question is clear to you. Let's move on to the next question.